Welcome everyone. In this video lecture, we will think about the SR latch circuit which is based on the CMOS circuitry. Okay. So CMOS SR latch circuit based on NOR gate. So we are using NOR gate for the SR latch. Okay. So the very first thing is our fundamental SR latch circuit is already drawn here using two NOR gate in which one of the two NOR gate, okay, 1 and 2. So in one NOR gate we are giving S as a input, and the other input we are just giving feedback from the output of the second NOR gate like this. And in the in the second NOR gate we are giving R as a input, and we are taking input from the output of the first one. Okay, so this one is our Q bar we are giving, and Q, and the corresponding CMOS realization can be easily done because this one is our NOR gate. So NOR gate, as we know how to make a two input NOR gate. So here I am making using two NMOS which are in the parallel, and we have to make it in series for the pull up network. Okay, and we are taking input to two transistor M1 and M7 as say S, and we are taking output from this terminal. So for example, I am saying this one is our V output 1. Okay, for the first node. Okay, so this point is our V output 1, and this point, say this point is our Q bar, Q is our V output 2. So this one is our V output 2. Okay, so V output 2 is connected to the input of the first NOR gate. So this one you have to connect here, and also one of the PMOS that we have to connect in CMOS. Again, here the output of the first one, first NOR gate is connected to the input of the second, okay, second NOR gate, and its complementary PMOS circuitry. So we have to make like this circuit. So this one is very simple. I have already made so many videos regarding the how to realize CMOS NAND gate, NOR gate, and their operation. Okay, so now fundamental. For example, this one is our CMOS, oh sorry, simply we can say SR latch circuit. So when both the inputs are 0, okay, both the inputs are 0, and so the output of the first node will be Qn bar, I am writing here, and Qn, okay, Qn for the second one, okay, and this operation is somehow we can say hold, okay, means when this one is 0 and 0 in when I, for example, when I am saying this one is 0, okay, and we are giving Q here, okay, so it should be Q bar, okay, Q bar, so that I am writing here, okay, when this one R is 0 and Q bar Q, so it is somehow hold, so it will follow the hold operation. And when it is 1 and 0, 1 and 0, so 1 and 0, so it is give a set value when it is 1 and 0, okay, then 1 plus q. So initially we are saying any value, for example s and r is our 1 and 0, okay, and the previous value of say q and q bar, I am saying the previous value anything, say 1 and 0 previous value. So when 1 and 0, 1 plus 0, okay, then 1 bar, 1 and 0. So again it is 0. So output will be 0 here, and 0 plus 1, 1, okay, 0 plus 1, 1 is there, 0 plus 1, 1, and again it is nothing but simply 1. Clear? So it should be our set value, means initially what it is 1 and 0, so we have to 1 and 0 set value, okay. Similarly for 0 1 it should be this set, and 1 1 it is not allowed. So this one is the truth table. So our aim is to just say what is the operation when we are considering the all transistor M1, M2, M3, M4, M5, M6, M7. So basically we have to do the operation part. Okay, means how the transistor is working in this circuit. So for this one I am saying, here I am writing S R Q n plus 1 and Q n plus 1 we can write, and operation. Okay, now here first of all we have to start with the anything, means suppose S and R. Suppose S is high value like 1, and R is, say I am saying 0, anything we can start. Or if we are thinking about in terms of signal, we can say S is our VOH and this one is our VOL. Okay, now when it is 1 and 0, as we observe that it should be 1 0 set value, so it should be again 1 0. Okay, so it should be our 1 and 0. And operation means here, so now this is 1 and 0, so 1 is our 1. Okay, so S is 1, so 1 is there, so M1 will be on. Okay, clear? M1 will be on, and R is 0. R is 0 means M4 will be off. So here simply you can say M1 on and M4 off. Okay, M1 on and M4 off from these two. Okay, now the other thing, it is simply we are saying this one is 1 and 0. So when it is 0, it is off, M4 off, because 0 we are giving to the NMOS. Okay, I'm making 1 is there, it is on. Okay, and 0 it is off. Okay, so now M1 is on, okay, and M4 is off. But in that case, M3, suppose M3, what should be the M3 operation? So M3 is also off because this is connected to here, Q bar. Now Q bar is our 0. Q bar is 0. Okay, Q bar is 0. So M3 is also off. M3 is also off, and M2. M2 becomes on. M2 becomes on. So M1, M2, because this one is our Q. So Q is 1, na? So Q is 1. So when it is 1, these two are on, and this one is Q bar is 0. So this one is also 0. So M3, M4 off. Is it okay? This one is only we are doing for the NMOS. For NMOS. Similarly, we can serve for the PMOS also. Means is if this one is 1, this one will be M7 will be off. I can write. M7 will be off. And then M5 will be again M5 is 1. That is our, it is off. Okay, and here this M8 is connected to Q bar. So Q bar is 0. So M8, Q bar is 0 means M8 is on. M8 on, and this one M6 on. Simple. Okay, so this one we can say the, okay, means this M1 M2, but you have to know this one M1 and 2 is NMOS, M3 M4 PMOS. So for 1 0, these are the condition 1 0 for VOH, VOL. Okay. Similarly, if we go for example, 0 1, okay, means VOL, VOH. Okay. So in this case, it should be 0 and 1. Okay. Then again, you can say when this one is 0, S is 0, so M1 will be off. So in this case, M1, M2 will be off. M1, okay, M1 and M2 will be off. Okay, when M1 is 0, okay, M1 is 0, M1, sorry, 1, when we are giving this one is 0, M1 is off. So M1, M2 off. So the other one, M3 and M4 on. Okay, because 1, this one is giving 1. So this one is on, M6 become off. Okay, so again, this should be other thing. So okay, so I'm just writing the NMOS operation. You can write it for M1, M2 on, then M7, M5 will be on. M1, M2 here on, here M1, M2 off. Then you say M5, M7. So M5 will be, M7 will be on simply because this one is 0, M7 will be on. Okay, I'm writing also. M7 on. Now it should be 1. It should be 1. Okay, it should be 1. Okay, and it should be 0. So when it is 0, M5 will be also on. M5 on. And this M8 and M6 will be off. Okay, this one is the other condition. Now when it is 0 0, now when I am saying 0 0, both are 0 0, means it is nothing but simply hold condition. Okay, so it should be either the value will be VOH or VOL or VOL or VOH because hold condition. This one is for hold condition. Okay, so in this hold condition, when both are 0, S and R, so M1 and M4 will be off. M1 and M4 because both are 0, M1 and M4 off. Okay, in both the cases, M1 and M4 will be off. But in this case, M3 or in this case, you can say M2 will be on. Okay, na? Because it will set value. So it is VOL. Okay, so M2 will be off because it is, sorry, M2 will be on. Okay, once again. So this M2 will be on. Okay, and similarly, or we can say M3 will be on. In both these two conditions, either M2 on or M3 on. So this one is simple realization. You can also go one by one step and you can write. Actually, in this video, my aim is to just show how to identify which transistor is on or off. So like that, you can say which transistor is on or off everything. Okay, so this is all about this video. Okay, so once again, one more time, suppose for any one point, suppose for example, I am saying in the last condition VOL is, okay, say this one is our S and R. One more example I want to show you, otherwise VR, and this one is our VOL, both are 0 0, means so either it should be hold. So any data like and Qn plus 1 or Qn. It may be either what? VOH or VOL. Anything. Okay. Means when it is 0 0, it is holding the data like 1 and 0. So means I am saying when it is 0 and 0, Qn bar. Qn is our what? Which one is our? This output is our Qn bar. Oh, sorry. This one is our Q1 and this should be our S1 will be our bar. Na? You can see S is our Q bar. Okay. So now this one is our Qn. This one is our Qn 1, and this one is 0. So when this one is 0, means M1 will be off, M4 also off. Okay. Now this one is 1, so M2 will be on. Okay. M2 will be on, and this one is our, so M2 will be on. Okay. And then it is 1, M1 will be, sorry, this one is 1, so M2 will be on. Okay. And so M3 will be off air. Okay. So is it okay? Like that you can do. Means, and this one is 0, so M7 will be on. M7 will be on. And when it is 1, so M5 will be off. Like that you can also do it for other one. M8 will be on, because PMOS is there, we are giving, and M3 will be on. Okay. M3 will be on. Sorry, M3 will be, this was 0, so M3 will be off. Okay. We have already written here. M3 will be off because this one is 0. So like that you can draw the, write the NMOS, PMOS operation, means in which region it will work. So this is all about this simple CMOS SR latch circuit based on NOR gate. So thank you for watching this video.